Hello, and welcome to Info Spark Zone. Tonight, we aren't traveling to distant galaxies. Instead, we are turning inward, toward a place so small it defies imagination, the Planck length. To find it, we have to leave our familiar measurements behind. We shrink past the grain of sand, past the cell, and even past the molecules that build life. Even at the scale of an atom, we are still too huge. If an atom were expanded to the size of the visible universe, the Planck length would still be just a tiny speck inside it. This tiny boundary isn't random. It is born from a marriage of three fundamental constants: the speed of light, the strength of gravity, and the graininess of quantum mechanics. This scale, the smooth map of the universe, breaks. The concept of distance stops making sense. It is the limit where geometry itself dissolves. Physicists call this environment quantum foam. It isn't empty space. It's a boiling soup of energy where space curves and shifts wildly from moment to moment. You cannot simply look closer. To probe this small, you need intense energy. But concentrating that much energy into one spot would collapse the space into a microscopic black hole. Think of reality like a digital screen. From far away, it looks smooth, but up close, you see the pixels. The Planck length might be the pixel size of the universe. In this view, you can't move smoothly. You have to jump from one unit of space to the next, like stepping on a staircase rather than sliding down a ramp. This is where our two best theories crash into each other. Relativity wants space to be smooth. Quantum mechanics wants it to jitter. At the Planck scale, they can no longer agree. Black holes taught us something strange. The amount of information they hold depends on their surface area, not the volume inside. This leads to the holographic principle. It suggests that our 3D world might actually be a projection of information stored on a 2D boundary at the smallest scales. Time might also be pixelated. The Planck time is the shortest possible tick of the cosmic clock. Below this, before and after lose their meaning. Some theories suggest that down here, there are no particles, only tiny vibrating strings. The Planck length is simply the smallest size a string can curl into. It may be that reality continues deeper, but our current tools are just too blurry to see through the mist. It comes down to information. The universe has a maximum resolution. You cannot pack more detail into a region than the Planck scale allows. But as we zoom back out, the storm quiets down. The chaotic foam blends together to become the smooth, reliable space we walk through every day. This stability is a miracle. The wild fluctuations of the smallest scales balance out to create the atoms and cells that make life possible. The universe is built on a foundation of uncertainty, yet it produces a world that is stable, predictable, and calm enough for us to exist. So, take comfort in knowing that the deep complexity of the universe is holding everything together, quietly supporting your sleep. Good night from Info Spark Zone. If you enjoyed this journey, feel free to subscribe, comment, and like the video.